Hey everyone! Today we are going to be adding and subtracting rational expressions. So let's take a look at our first few examples. Now before we start to add and subtract rational expressions, again we like to relate it to the process that we take when computing the numbers. So what if we wanted to add these two fractions together? Remember, when we add fractions together, the first thing we have to do is obtain a common denominator. So for example 1, we have a denominator of a 3 and a denominator of a 7. Well, since 3 and 7 do not have any common factors, we simply just multiply the first fraction, the top and the bottom, by 7, and the second fraction, we multiply the top and the bottom by 3. The reason we did this was so that we could obtain a common denominator of a 21. When we are adding two fractions together, we have to make sure that we end up with the same common denominator. So in this first example, I have a 7 over 21 plus a 6 over 21. Now that I have my common denominator, I can now combine the two numerators by addition. So I add my 7 plus 6 in the numerator with the denominator of a 21, and we end up with 13 over 21. And this is as simplified as we're going to get. Again, just to reiterate this process, let's consider adding two fractions together that actually have some factors in common already. So what we do is we find a common denominator. Now what we could do, just like we did over here in number 1, is simply multiply the two denominators together and get a denominator of a 16. But that wouldn't be the least common denominator. What we want to do is have answers in simplest form, so we try to deal with numbers that are smallest as possible. So, considering this denominator as a 2, and this denominator as a 2 times 4, we could actually think of multiplying the top and the bottom of this first fraction by just a 4 instead of a 2. So what we're saying is the common denominator is going to be 8. So let's multiply the top and the bottom of this first fraction by 4. So we end up with an equivalent fraction of 4 over 8 plus 3 over 8. Now that I have a common denominator, we can add the two numerators together by addition over this common denominator and write our final answer as 7 over 8. Now that we've used that example as a warm-up, let's consider what we would do if we wanted to simplify a rational expression such as number 3 and number 4. Notice we've got rational expressions involving variables. So our approach is going to use these helpful steps for adding and subtracting rational expressions. So the first thing we want to do is factor the denominators if necessary. In this case, we just have a 3x and a 2y, so that's not necessary. Now let's look at step 2. Identify the least common denominator, which is the LCD. So this is a term we'll refer to frequently from now on. An LCD is the least common denominator. So looking at these two denominators, I have a 3x and a 2y. Since these do not have any common factors, the LCD will be the product of the two. So let's multiply this first fraction, both the numerator and the denominator, by a 2y. And the second fraction, let's multiply both the numerator and the denominator by a 3x. Again, this is so that we can obtain a common denominator, which we've already identified to be 6xy. Now that we have this common denominator, Let's simplify by multiplying the numerators together. Negative 14xy squared over the 6xy plus, remember we're adding these two together, so we'll add and multiplying these numerators together. I have a 3x times a 4y squared. So what we have here is the product of 12x y squared all over this common denominator that we've already found to be a 6xy. Now that we have a common denominator, we can now just add these two numerators together by addition. So my final step, I add those two numerators by addition and rewrite my expression as negative 14x y squared plus 12x y squared all over the common denominator of a 6xy. Now, since our two terms in the numerator happen to be like terms, remember like terms need to have the same variables and those variables need to be raised to the same exponent. So, negative 14xy squared and positive 12xy squared are like terms. Combine them by adding the coefficients. I've got a negative 14 and a 12. That will give me a total combined answer of a negative 2xy squared over 6xy. Now, let's cancel common factors. Once we get to this step, we want to make sure that we cancel any common factors just as we have been doing in our simplifying of rational expressions in the past few weeks. So, let's note that we can cancel these two x's. Our exponent of our y is larger on top than it is on the bottom, and the 2 cancels into the 6. So, I'm going to say that 2 cancels with my 6 3 times, and the x's completely cancel. And since my exponent is larger on top, I'm left with a y raised to the 1. Remember, when we write our final answer, we like to carefully scan across. We've got a negative, a 1, and a y on top. So we'll write that as negative y. And then in the denominator, we have just a 3. So remember to carry that over. Our final answer is negative y over 3. Now let's consider what we would do in this example. Notice we have subtraction as our operation. What we like to do if we are simplifying with subtraction is actually just give this negative to the numerator, and that way it changes my process by only taking the opposite of what we're left with in the numerator. Now we can approach this just like we did in the previous example. Now let's observe that we have two binomial denominators. Our first binomial denominator is an x minus 3. Our second denominator is an x minus 1. So remember, in our steps for simplifying, the first thing we want to do is identify the LCD. So in this case, my least common denominator is actually the product of the two denominators that we have. So I have an x minus 3 times an x minus 1. So what I'll do is multiply the top and the bottom of my second fraction by x minus 3. And I'm going to multiply the top and the bottom of my first fraction by x minus 1. So notice what this actually did to my overall expression. I've now obtained a common denominator of an x minus 1 times x minus 3 in this denominator, x minus 1 times x minus 3. So what I'm going to do in the next step is multiply my 2 through to my x minus 1 to get 2x minus 2 with the denominator of an x minus 1 times x minus 3. And remember, I'm adding that to this entire expression with the same denominator. So I'm going to write it as negative x plus 3 as a result of distributing this negative 1 through to my x and through to my negative 3. So I get a negative x plus 3, and in the denominator, the same as our LCD. So let me write that as x minus 1 times x minus 3. Now that I have two rational expressions, this entire chunk and this entire chunk, with the same denominator over here as I have over here, I can now combine my two numerators, the 2x minus 2 and the negative x plus 3, by addition. So let's combine like terms. I've got a 2x plus, 2x minus 2 minus x plus 3, all in the numerator with the denominator of x minus 1 times x minus 3. Set that equal to the 2x minus x gives me an x, and the negative 2 with the positive 3 gets me a total of positive 1. And in my denominator, I am left with x minus 1 times an x minus 3. Do not be tempted to cancel any of our terms at this point, because remember, we can only cancel common factors, not terms. I have an x plus 1 factor on the top, an x minus 1 factor on the bottom, and another factor of an x minus 3 on the bottom. Now example 6 is completely simplified. Before we move on to the next example, let's just revisit what are recommended steps for simplifying a rational expression with addition and subtraction. So the first step, remember, it's to factor the denominators where possible. This next example that we'll do is going to require factoring our denominators. Then after we factor our denominators, we want to identify the least common denominator. After we factor and identify our least common denominator, we'll create fractions with like denominators. We'll then combine like terms in the numerators, factor the numerator if possible, and then simplify. So let's carry this step-by-step process. Again, this is just to remind you of the steps you should be looking for. Now let's look at our next example. In our first fraction, we have a trinomial of the form x squared plus 2x plus 1. And in the second denominator, we have an x squared minus 1. Each of these denominators can be factored. So let's do that here. The first denominator, we end up having an x, we have an x and an x and a 1 and a 1. Now remember, we're trying to factor the x squared. The only way of factoring that is an x times an x. The last term is 1. The only way of factoring a 1 is a 1 and a 1. Then we have to consider our sign placement. This last sign is positive. That means that both of these signs will be the same as the middle, since we know that a positive times a positive gets you a positive result, and a positive plus a positive gets you a positive sum. So we've now factored this denominator. So I'm actually going to cross off this denominator just so I can recognize that this is my new denominator in factored form. Now let's factor the second denominator. Notice that we have a binomial which represents the difference of two squares. So let's factor this as an x plus 1 times an x minus 1. That's what we had already memorized as our pattern for factoring the difference of two squares. Now that we have factored both of our denominators, let's consider what our least common denominator would be. Now, in order to do that with binomial and polynomial denominators, is to try to find all of the factors that exist in one denominator that are missing in the other. Since I have 2x plus 1 factors over here, but I only have one over here, I know that I need to duplicate an x plus 1 factor in this denominator. Let's also recognize the factors that are missing in the first denominator that I have in the second denominator. I'm missing an x minus 1 over here that I have over here. So let's correctly identify the least common denominator to be an x plus 1 squared times an x minus 1. So what we need to do is multiply the top and the bottom of our first fraction by an x minus 1. So let's wrap parentheses around any of our binomial numerators. Now in the second example, I have an x plus 1 and an x minus 1. What am I missing up here? I'm missing an x plus 1 factor. So let's multiply the top and the bottom of the second fraction by an x plus 1. So I have to wrap parentheses around my numerator that already exists, which is an x minus 1. And then make sure that I'm multiplying that entire numerator by the x plus 1. Let's multiply the denominator by the x plus 1. So let's just recap what we just did here. I have an x plus 3 times an x minus 1, x minus 1 times an x plus 1. This is going to be my new numerator over here, and my numerator over here. And I have now a common denominator of an x plus 1 times an x plus 1 times an x minus 1. So let's simplify by combining like terms and multiplying. So what I'm going to do in the next step is FOIL my numerator on this side first. So I end up with 3x squared minus 3x plus 3x minus 3 plus the result that I get when I FOIL this numerator. So I've got my x minus 1 times my x plus 1. Let's write that down right here. So when I FOIL this result, I get x squared plus x from the outer product minus x from the inner product minus 1. So what I've done here is I've FOILed this numerator, placed it here, FOILed this numerator, placed it here, and this is all expressed over the denominator of our LCD, which we have previously found to be x plus 1 times x plus 1 times x minus 1. Now let's add like terms in our numerator. So we have a 3x squared term and a 1x squared term. That ends up being 4x squared. Then we have a linear 3x, that's a negative linear 3x, a positive 3x, an x, and a negative x. Well, actually, all of these cancel, so we do not have a linear term. Now let's look at our values of our constants. I have a -3 and a -1. Combining these two together, we end up with -4. Remember, this is all over my LCD. And I'm just going to write it like that for my intermediate step because I actually want to factor this numerator. I can take out a 4, and I'm left with x squared minus 1. Well, hey, what does x squared minus 1 simplify to? Or factor to, I should say. It factors to an x plus 1 times an x minus 1. And then this is all expressed over our least common denominator. I'm going to now write out my least common denominator. And that common denominator is x plus 1 times an x plus 1 times an x minus 1. Notice what we get to cancel. We get to cancel the x minus 1s and the x plus 1 factors. Now we're only left with a 4 in the numerator and an x plus 1 in the denominator. So let's express our final answer as 4 over x plus 1. Now that we have seen examples of how to add and subtract rational expressions, we're now done with our lesson.
Made with Doodlecast Pro.